Check, check. All right, guys. Heck yeah, a lot of work to do today. A lot of work to do today. Let's do it. Oh, hey everyone. I hope you can hear me just fine. Welcome back to Better Biomed. Oh my gosh, I have quite the project that I'm working on, and it's going to be a fantastical day. So I've got a bunch of products that just came in. I haven't even unpacked them yet. So the intent is to kind of lay out the products, how they're going to go on here, and see if I have everything I need to go forward with this project. So what we have here, this is a DC trainer. In fact, let me tell you, let's just go ahead and turn on the other camera. I should be better prepared. I know. All right, cool. There we go. All right, now we can just switch it on over. Ta-da! Here we go, guys. All right, so this is my DC trainer board, and you can see I have a regular 120 volt in, where it goes into a fuse block and junction, and from there it splits off into a bunch of other things. There is a method to this madness. So a couple of things that I think you guys should be aware of is the power comes in, and just like with regular medical devices, up here I've got line and neutral, both of them are fused. And the reason that they're both fused is because just like with medical devices, you could end up with voltage on a different leg. Like instead of neutral, if you're plugged into an isolated power system, you could easily have voltage on another leg. So that is why both of them are fused. And then it goes into an e-stop. You'd probably be like, why would I have an e-stop on this? The reason being is because so many medical devices out there, they will have an e-stop on them. And the fact of the matter is, if you plug it in and it's not turned on, you're like, what the heck's going on? Always look for an e-stop. And if you see one, you should always depress it and then reset it. All right, if you have a device that's not turned on, you always press it and then reset it, just to be sure, all right? And it's exactly like that on this one. Now from here, I have 4 different power supplies. And you can see I've got a external switch mode power supply. I've got an open frame, I've got a closed frame, and then I've got a generic unit out of a Connex. So the wires exit, they go on the behind to these 4mm banana plugs, and that's because I want people to be able to build their own circuits, and that's what we're going to be doing over here. Also, right here on your power switches, I'm going to have red on both sides so that you can open and close the circuit and see what's happening, all right? Because this is exactly how it is on devices. You have your power supply, and then you have some sort of disconnect, usually a relay or something like that, and then it goes on. So this is all for helping people with their troubleshooting. Now, you're probably wondering why I have these 2 active cooling fans off to the side. They're clearly not doing anything, but the header is on the power supply. It does exist. So it is just one more thing that people should be looking out for, because if I induce a bug and the cooling fan doesn't start when the unit powers up, well, that should tell you immediately, hey, wait a minute, something's going on here. Because these type of power supplies here, that header should be hot all the time. As soon as it got power, this guy should be spinning up. Is it spinning? Is it not? That'll help you troubleshoot it. Now, I will tell you that 2 of these 4 power supplies are defective. 2 of them. And I left that way on purpose, because people need to know how to troubleshoot DC power systems, all right? Down here, I have a battery, and yes, I just have a couple of alligator clips on it. And on the reverse side of this board is a float charger for this battery. So the float charger is, I think I'm gonna power it off this guy up here. And that is because these circuits over here could run off the battery even when the system isn't powered up, just like medical equipment. So we can actually induce some problems by having this battery. Have you checked how to charge the battery, right? Is your charging circuit working correctly? How about your battery minus your charging circuit? Have you checked it to make sure that it's got the correct voltage? Because a lot of systems, if your battery is on low voltage, your charging circuit will appear like it's defective, because it says, hey, this battery is defective, so it won't even enable the charging circuit. So all that's going on. Today, I'm gonna be working on this over here, and I have a whole bunch of stuff that I'm gonna be hooking up. So I said, what's a better way to show people DC circuit theory than with motors? And I don't have just any motors. I've got every type of motor that runs off DC, all right? So let's go ahead and let's switch the camera over, and I'll show you guys a little bit of what I'm talking about over here at the desk. Great, okay. So some of my DC motors, this one here is a, 24 volt? 24 volt air pump. I can do some really cool stuff with that, obviously. One of those power supplies is a 24-volt power supply, but just the same, people should be reading labels. All right, if this says it's a 24-volt pump and you hook it up to a 12-volt power supply in your own circuit making system, it's going to run abnormally slow, and as soon as it encounters a load, it's not going to keep going. That's something people should always be aware that their systems are marked. So I've got this Pitman right here where I was thinking about just putting a flag on it so that people can see it spinning. And this is actually a pretty heavy-duty motor. I have a couple different PWM controllers slash stepper drivers, and I've got to find a way to make these work, and that is what these boxes are for. All right, so I'm kind of going to have to lay these out, figure out what I have. I also have some other sensors. I'm not really sure if I'm going to make them work or not. Like this guy right here is a light sensor. So I could technically put that in circuit someplace, also make that, you know, part of the problem or part of the solution. So let's see, what do we have here? I have not opened these yet, so I'm a little curious myself. Sometimes when I'm thinking late at night and I'm ordering stuff off like Amazon, I think, wow, that would be such a cool idea, and I order it because it's so easy, and I forget what I ordered. So, and okay, how about this? Just by looking at these, I'm gonna have to figure out what they do, because honestly, that's as real as it gets, man. I don't remember what they looked like, and I've got like 3 different motor controllers here, so just basing off the looks, I'm gonna tell you guys what it is. So this one right here, it's got 2 pins for DC voltage in, and it's got plus and minus motor out. So this is a 2-pole DC PWM controller, okay? So you can see right here, it's on, it's off, forward, reverse. Okay, there it is. Off, on, there you go. So you're gonna control the duration of the pulses here. So if it's 12 volts in, it's going to pulse 12 volts output. So the longer the pulse, the faster the motor is gonna go. And this guy here is controlling 2 little drivers, which are underneath the heatsink right there. So this is a 2-pole, which means I could use it with this guy, or I could use it with this guy. So the plan is to have the banana ports next to it so people can build their own circuits. That's the plan. Since this is a 2-pole and this is a 2-pole, people can learn to build, you know, I can speed control my pump or my motor that's gonna have a flag that's gonna flip around. It shows speed. Okay, so I know what that one is just by looking at it. Let's see. Of course, I'm gonna probably be building up a lot of trash. This one here is in Chinese, so we don't know. Oh, well, yeah. All right. Well, that's kind of a dead giveaway. So this is a stepper driver, okay? And a stepper driver actually needs this guy right here. So linearly, it's going to be like this guy has the voltage come in. It tells the direction and the enable pin. So if you want it to go clockwise, counterclockwise, and the amount of pulses. So this one here generates the pulses, and each pulse on this guy tells it to start to rotate, all right? So a stepper motor, let's see, hold on. I got a stepper motor in here. There we go. So I'm gonna also have a little stepper motor mounted to my board. So this guy right here, this one is almost definitely gonna be connected to banana ports. And that is because if you short the leads together, it will spin from really easily to it's really, really difficult. And that is because you are creating like eddy currents inside the motor. And that's one of the things I want people to get used to. That's how you find the poles of a stepper motor, is you put the leads together. First off, that's how you test a stepper motor, is you short the leads together and then you try and rotate it. It's generating electricity. That electricity is shorting out here, which is inducing an eddy into here, and it's preventing the spin. It's very difficult to spin. So on this particular stepper motor, it's a 2-pole. So you'll have 1 pole, 1 pole, 2 different coils, and you have to find which ones are those coils. So the way you do it is you spin it, you touch 2 wires together, nope, no resistance, touch 2 more wires together. Oh yeah, right there. I can do it with my fingers, but it's very difficult. And I can feel it like pushing back against me trying to spin it. So that's the cool thing about stepper motors, and it's something that people should know, is that stepper motors, they're not like any other motor. You can't just hook it up to a battery and have it spin. That's not how it works, because it's got all these different poles. It's got technically 2 poles, 2 different coils, but the 2 different coils are everywhere. So it's here, 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 and then in between those is the other set of coils. And that's what makes a stepper motor positional. So it will move from this coil to that coil, to that coil, to that coil, to that coil. And that's why you can gauge exactly where it starts and stops. Cool thing about steppers, awesome opportunity to teach people about the components of a stepper system. So this motor is going to connect to this guy, and this guy right here is the pulse creator. So we can make it spin faster, slower. I can reverse it by hitting this guy right here, and that's going to be your directional. And this is just a driver, and you can see on the driver, oh, come on. You can see right here on the driver, there's 2 separate coils. You see it's what? B minus, B plus, A minus, A plus, right there. So that is, you have to first find the 2 pairs, and you do it by shortening them together and trying to spin it like I did. Once you find them, then you attach them here. So you're gonna have a direction signal, and you're gonna have an enable signal. And those are gonna be generated by this guy. It says right here, pull, direction, enable. Ta-da, too easy. And then you have your 20 to 60 volts in. Cool stuff. I always wanted to build this to teach people about stepper motors because they really should know. So there we go. We got a 2-pole DC motor, brushed motor for this guy. This guy here is for a stepper motor. This is a brushless motor. And let's see, I don't completely remember what this guy is. What is this guy? Okay, it's got an on-off switch, and I've got a speed. Oh yes, okay. All right, hold on. Let me grab a motor. Oh my gosh. All right. Let's see. I just tore something apart a day ago. Yes, here we go. So one day ago, I tore apart a Phillips, and this is a CPAP, and I said that it has a 3 wires going into this guy, so that makes it probably a 3-phase brushless motor. And a 3-phase brushless motor is also what you see in almost every one of these modern day tools. That is a 3-phase brushless motor that's in here. So you'll have 3 wires coming out of the motor, and that is what this is. So the reason that we have this configuration, all these heat sinks right here that you can see, is because they work in pairs, you see? So when you create a plus on a sine wave, you're gonna create a minus on a sine wave, and then a certain number of degrees later, you're gonna have a plus and minus of the next sine wave, and then a certain number of degrees later, you're gonna have a plus and minus of a sine wave. So they have to work in pairs. That's why we have 6 semiconductors in here with heat sinks. So this is a 3-phase brushless controller. And mind you, almost every one of these components I bought extremely cheap on Amazon. Like this one here, this PWM controller for a 2-wire motor. This one was $9 if I remember right. The brushless motor right here, the stepper, that was like $10, $12 something. This guy here was like $10 or so dollars. I mean, for this whole entire demo, it's probably less than $100. which is incredible. But the cool thing is with 3-phase, if I wire this up correctly with the banana plugs, which I do have a bunch more banana plugs, the goal is so that people can actually use an oscilloscope to see what's happening. And that's the cool thing. Now with a 2-channel oscilloscope, you could actually hook it up, one to each of the 3 wires, one of these 3 wires. I know that there's more than 3 wires in there. That's because the other 2, I believe, are for a speed sensor. But there are 3 wires right there. You see they're kind of silicone jacketed. So 3-phase, brushless motor. This is the exact kind of turbine that you'd probably find in like the new Draeger anesthesia machines and stuff like that. So exceedingly fast, very reliable. And the cool thing about 3-phase motors is you can control the speed so well. So with this guy here, I believe we can reverse it too. Now, if you ever want to reverse a 3-phase motor, you've got 3 wires connected. All you gotta do is take 2 of the wires and cross them. So you change one of the coils, you flip the wires, and all of a sudden now it runs in the complete opposite direction, which I do believe is what they're doing with the microchip on this guy. See, this guy isn't physically switching a micro switch like the old ones used to. I believe that this is just switching over on the microchip, telling it to reverse the polarity on one of the coils. And that is why the drill runs in 2 different directions. How crazy, huh? It's just switching one of the coils over, and now the motor runs backwards. So that's what this guy is. So we have a 3-phase motor, we have a stepper motor, and I have a single phase, which is, you know, plus and minus, but that's a PWM controller. And the cool thing is, PWM, you can see it on an oscilloscope. You can see a little square pulse, and then that square pulse will get longer, and it might go always on. I have no idea. We'll have to, when I'm done, we'll have to check it out. So any 2-wire, like even this one here, I could banana plug connect up to this guy, and we could run it, and we can adjust the speed. So cool. So I don't know which motor I'm gonna use as part of my demonstration for the 2-wire. I was thinking this guy right here, because what I was gonna do is run a little hose up to like a little balloon, so people could see when you turn it on, it inflates the balloon, but it's going to inflate the balloon at a variable speed based on this guy right here. And also, if I connect it just so, like with a rigid enough balloon, then as soon as this guy reaches a certain amount of pressure, which isn't going to be much, it's going to low down, it's going to load up, and it's going to stall. And that is because I have a 15 volt, I have a 12 volt, I have a 24 volt power supply, and depending on which one you connect to it, if you're not reading the numbers, it's going to stall. All right. What's up, Catherine? How you doing? So I was going to build this anyway, so that's why I said, you know something, I might as well just turn this on, and if I'm going to figure this out, I'm going to figure it out with you guys on camera, and if something catches fire, it catches fire. Who cares? So what I really wanted to do is, for years now, I've had this little 3-phase kit. I guess I should have used this when I was explaining my whole 3-phase. So this is a hobby motor that you would see on an RC car, and this is an ESC, that's electronic speed control. And you see I've got my battery input right here, and I've got an on-off switch, and then this guy right here is actually a serial bus. Like, it uses serial data, and it's supposed to connect to a controller. Well, at first I thought I was going to be able to control it with this guy, but this guy's just to program the ESC. Once you're done programming it, that guy there has no job. So I need a controller in order to make this guy work, and it was just cheaper and easier for me to just go out and get, you know, this little, this PWM controller right here. So I could hook this motor up to this, and it will spin. It most certainly will. These are just banana plugs and sockets. See it? And just like I said on this guy, if I take any 2 of these wires and flip them around, now the motor will run the opposite direction. So if you have an RC car that's running like backwards, and you know, when you squeeze the trigger and you want it to run forward, you just reverse 2 of the wires, plug them back in, now grip the trigger, and now it will go in the correct direction. That's the crazy thing about them, you know, so it's not very difficult to troubleshoot. I honestly have no use for this, and if any of you guys are interested, I will ship this out to you. I was going to use it. I have no use for it. It's not the cheapest thing in the world, but if anybody's into like hobby racing or something, let me know. I'll maybe hook you up because this is a little badass motor too. Don't get me wrong. This is 120 amp ESC. 120 amps. That is insane, guys. So it is an absolute beast, but I can't use it. So instead, I'm gonna get this guy right here. So what I have to do is I have to connect wires to these ports and then run the wires to the underside of the board, and then they're gonna come up to female sockets, like these guys right here. So these are banana plug sockets. See it? There you go. And I'm using an awful lot of red ones on this project. So for the 3-phase, I'm going to use black, black, and black because I have a lot of reds, you know, that are being used. And I've got a lot of these sockets. I'm going to use quite a few of them. Okay, so this is definitely a project I've been working on for a while. So maybe I should just shut the music off, right, guys? Okay. Let's go ahead and flip over to the board, and I've got to figure out how I'm gonna mount these. I think this one here is gonna be easy because it's got this large flat pan on the back. I can mount to that, and I kind of wanted it to blow towards the person because this guy's gonna kick out a massive amount of air. Very efficient design right here. This guy here, I was thinking one of them is suction, one of them is blow. So I was thinking on the blow to hook up like a little balloon or something to you know, give somebody a physical representation of how fast that it's working. I don't know. Still kind of thinking about how I'm going to implement that, because the chance is I don't know, maybe I can come up with a socket so that people can stick a balloon on there, inflate it until maybe the balloon blows off and psh, goes around the room. Something like that. You got to remember, I'm going to be using this training aid around kids. You know, high school kids, college kids, whatever. They're still kids. I mean, everybody's a kid to me. So, but okay. So I've got this one. I've got this one here. I guess the next goal is I have to get some wires connected up to these. And for all of that, I'm going to use ferrules. All right. So I'm a big supporter of using ferrules. I guess the motors I can set off to the side, because at this moment I'm more concerned about all the controllers. There we go. This guy here. Let's start with the 3-phase. 3-phase, since this is basically modern day motors in a nutshell. I mean, almost everything is brushless motors now. They're all 3-phase. Most modern day nice treadmills are all 3-phase motors. Most nice woodworking tools, most tools in general, are just going to be 3-phase. So this one here is going to be one of the most important. All right. And maybe I'll have this one here set up as well, so that they can switch between the two motors. So this one's a 12-volt motor. This one's 24-volt. And let's see. This one's a 6-volt. Maybe I'll do something so that I'll maybe hook one of these guys up as well, just so that people can blow it up. Why not? Why not? It is what it is, right? But definitely the 12 and 24 volt. We can definitely interchange the voltage between these two without doing too much damage. Okay, let's get the ferrules and let's go ahead and figure out how we're going to run these wires. All right, let's see, ferrule kit. So I have many, many, many boxes of stuff. I've got crimps, I've got ferrules. So this ferrule kit right here, woo, that is just blinding right there. Okay, so in here I've got hundreds, if not thousands, of ferrules, and it's gonna just make my life so much easier when it comes to plugging and unplugging things. Let's see. Now this might be a little too heavy of a gauge. Let's see. This is 12 gauge. Okay. So the reason I chose 12 gauge wire, stick with me guys, is because when you create, when you create test leads, so I have to make up a whole bunch of leads like these. You see that? So that people can plug in to, you know, to their ports and design a circuit, you know. So they're going to run a wire from here to here, here to here, and that's why I went with 12 gauge, is because the wire is much sturdier and much easier to work with. I have a lot of work ahead of me, guys, a lot. So I don't think I should wire up these guys with 12 gauge though. Geez, that's kind of heavy. Let's see what we got going on here. So I already gave one presentation live with my AC troubleshooting board. That's the one that's back there. And it's currently covered up so that nobody messes with it, and so it stays safe and clean. And it went particularly well. You know, it's that one over there is a mock-up of a real AC system that you'd find in a house or a hospital. And it allows you to safely troubleshoot things and to give an explanation of how it works. Now this system, DC is just inherently safer. So that's why I have all the cables and stuff so that people can make their own circuits. Wow, they really wrapped the heck out of this. And I need to sharpen my knife, clearly. All right. Let's see, 12 gauge. Oh, Jesus. That is a hefty cable. It will be perfect for making leads and jumpers. Not so perfect for what I need to do. Okay. Let's see. I have a lot more cable. That's an understatement. Let's see. This one here is, that looks more like a 14 gauge, 16 gauge maybe. And let's see, what else do I got? That one's not so soft. I really don't want to run to a store and buy some more cable. I got some yellow. All right. What else do we got? And some blue. Nice. Nice. Okay. All right. Who cares about color code? All right. So, let's do one at a time. One at a time. See, that's the thing is, like, every flat surface in the shop, when I work on projects, gets very involved really quickly. So, I know, even right here next to me, I've got a flat surface that's just full of stuff. So, let's see, let me shut this guy off. Save some battery. Okay. And, whoop. There we go. Okay, so I've got some blue cable. I've got some red cable, and I got some yellow. Nice. Which, basically the colors I need if I'm going to do something like three-phase. Let's move that stuff over. Put this guy up here. I was going to do a whole nother movie, Jesus. I was going to do a whole other video on DC motors and just take you through a rundown, but maybe after this board is done, maybe I'll still do it. Okay, wow, what a mess. All right. I got a new set of crimpers that I haven't showed anybody yet. These are super nice. Definitely better than doing it with, you know, the backside of these pliers. Definitely. I do need my other set of strippers though. Otherwise, this project's going to take forever. Here we go. Okay. These are going to make this job so much easier. Okay. And these guys can booger off. Good. So the first one I'm going to work with is going to be the 3-phase. And in order to make this guy work, I need, let's say, about 4 to 5 inch sections. So we'll do 1 red, 1 blue, 1 yellow, 4 to 5 inches. There we go. And yellow. I need to update my wiring. I don't have too many wires. After building several CNC machines, a lot of my stock of consumables like wiring is kind of running low. All right, those guys can all go over there. Okay, so the first thing that we gotta do is prepare it for fair rules. So I'm stripping back about 1/4 to 3/8 of an inch. Okay, and let's see, for these ferrules, we go with this little gray jobber right here. Beautiful. Perfect. And then that's why I have this guy here for, is to cut it off. Here, I'll just trim it right here in the tray. And then each of these wires is going to get screwed down right here inside these wiring terminals. And that's going to be my CB and A, right? So each one of them has to be finished up first. Like so. Nice. All right, so now that I've got all 3 of those done up, let's see, what am I going to do about the other side? So the other side's going to have to connect to a spade terminal because it's going to go through the panel, and then on the back side it's going to connect to the female of these, right? So see the spade that's on the bottom? So one side gets the screw down, the other side gets the spade, and they're going to go to these. All right, and let's see, what did I do with my screw down, or my crimp terminals? I just had them. I do have heat shrink terminals, which are these guys right here. And let's see, where's the female spades? Right here. Cool. 1, 2, and 3. I need more workbenches, guys. I think that's pretty much how this comes down. I need more workbenches. Okay, so this guy here. Uh-oh. That's the wrong terminal. Okay. Some of these guys are all mixed up. I'll have to be careful about that in the future. Okay. They're all female spade terminals. There we go. And my new crimp pliers. This. Oh, that's so easy. Actually get a really good crimp on those too. All right, next. Okay, there's two. Right, here we go. And number 3. Excellent. So this guy here, I've never used this style crimper before, but they do a pretty darn good job on crimping down. Except that one there, I can see it didn't, so I pulled it out. There we go. Let's do it again. There we go. Let's double check them. I'm more of a fan of soldering terminals because I know it's going to be securely locked in, but this would be a lot of soldering. Okay, let's put this guy over here. So each of these is going to screw down to this guy, and that would be this one right here. Okay, so that's the 3 for the 3-phase. Now I need to create the power wires for the DC plus and minus. And let's see. Oh, what should I do those out of? This right here. It feels almost like it's too thin of a gauge. I'm not going to use those. Why not? This is way overkill, but that's what I'm going to use. Come on, open up. All right. You can see I'm just going to separate the 2 conductors like so. There's one. The reason I went with a heavier gauge is because 3-phase motors can suck a lot of current, and that other wire that I had just probably wasn't going to cut it. I don't want it to melt. I never know what I'm going to hook up. I would rather have the infrastructure heavier than the board. So if I blow this board, I'll just buy another one for 10 bucks. I don't care. But I don't want to melt the wires, you know. Okay. Jeez. Definitely stepped up the gauge. Okay. So the fair roll, okay. For the fair roll, you can see all it is a collar. I slip over the conductors, we crimp it, and then when it's crimped, come on, this camera. When it's crimped, it's on there. It ain't going nowhere. And that allows me to be able to plug and unplug as many times as I want without fraying the copper, which is super important because with the training aid, you want to be able to create problems and have the students figure out what went wrong. So this is a maintenance and longevity issue. There we are. So that's my power for this board. They do fit in there, right? Yeah, barely. Here, let me check that just to be sure. So once I get all the wiring and everything figured out, that's when I'll take them over and I'll start mounting them on the board. Ooh. It's a tight fit. I mean, it'll go, but it's a tight fit. Okay. Oh well, we'll cross that bridge when we get there. So that's the screw down terminals. Now as for the power switch, I haven't quite figured out how I'm going to implement these switches, because I think what I was going to do is create a L bracket. So that would be a piece of sheet aluminum, or not sheet, but what the hell is that stuff called? I've got some angle bracket aluminum, and all you got to do is drill through it, mount the switch down through it, you know, and especially like this one right here, because there's not too much space between the body of the potentiometer and the knob, so it's gonna have to be like sheet metal that this mounts through. That board that I have over there, that's, I don't know, it's like 5/8 thick, so I couldn't do that. And I can't just glue them to the front, like, I think that would look janky. So I think it would be better to have some L bracket and then you mount it to the L bracket like so. Create like a little panel. Okay. So that's this guy right here. Next, let's see. Let's start messing with the stepper. The stepper is obviously going to be the elephant in the room when it comes to setting up, because there's 3 different components. Like, all right. So this is the pulse creator, and the stepper motor's at the very end. And what I'm thinking about doing, because it's got these long, really nice looking leads, is just going ahead and securing these directly to the banana plugs. So this guy would just connect straight to banana plugs, and that's it. That's the end. Or I connect them up. I can connect them up formally like this in a line, and then they just stay connected all the time. That might be how I have to do it. I really wanted to make it so people could move stuff around, but you're creating too much chaos, especially with steppers, because you do have like enable, direction, pull. This is really kind of a hard one, because I would like people to learn how to set up a stepper motor, but I have to like balance that out with how many people are really going to learn that stuff. Anywho, I'm going to chop these wires right here. Let's see. Where is my cutters? I don't need all these wires. Right there. Okay, I'll save these because there's a good chance I'm going to use them for connecting between those two. And let's go ahead and strip them back. Okay. And this one. So these are really small conductors. Now, I told you guys I have to find the pairs. Now, there is a sheet right here. So there's a sheet right here that's a data sheet that tells you about the coils, and it tells you about braking resistors and some other stuff. But that's okay. I'm going to do it the way that I showed you guys. So let's take two conductors. Let's try the green and the blue. We're going to touch them together and try and spin it. Yeah, that's no problem. Okay, so let's say the green and black. Oh yeah. So these two right here are one coil. So let's go ahead and set those guys up for ferrules first. Wow, I have some tiny ferrules now that I'm looking over here. Tiny. This is like a 24, 26 gauge cable. It's pretty small. Okay, 1, 2, 3, 4. So that was green and black. I don't think I stripped those back far enough. Come on. There we go. Okay, give them a little bit of a twist. Okay, black and green. Nice. So much lower maintenance to go ahead and ferrule your stuff, guys. It takes a little bit of investment and time in the beginning, but the fact that I can connect and disconnect this is such a lifesaver when it comes to troubleshooting. So the rest one is going to be red and blue. So again, we're going to touch them together, try and spin it. Oh yes, definitely some resistance. You can see it try to move the body of the NEMA. That's a NEMA 17 stepper motor. So the size of the body of the stepper motor is a different NEMA size. So they call it a NEMA frame, which is a standard motor size. So this is a NEMA 17. There's ones a little bit bigger that a lot of people use on CNC machines and 3D printers called NEMA 23s. And then there's, NEMA 32s or something. But yeah, this is a little NEMA 17. Cute little motor. Extremely powerful considering its size. There you go. Nice. And last one. I have an idea. Since I'm going to have all these up in ferrules, when I want somebody to wire up and figure out how to wire up a stepper to a controller, I'll just pull them out. Just pull them out and make them find the pairs and then make them screw them down. I mean, this part right here is actually pretty inexpensive. I think I bought it for, how much was this guy? It's like $10, $12. So even if somebody breaks a terminal block or something, which, check this out. You gotta love industrial electronics. The terminal blocks can disconnect from the component. See that? So if I want somebody to wire this up, I will have them do it. I'll just disconnect everything. If they break it, they break it. Who cares? So this here's one of my coils. So right here is B. You can see right here there's symbols for A. Doesn't matter which one's which. Let's go ahead and loosen those terminals up. For all I know, this thing's going to catch on fire as soon as I go, as soon as I try to plug it in. You really honestly never know with some of these Chinese electronics. That's okay, because it's inexpensive, and I consider right now the perfect time to learn electronics, because a lot of things that we get from overseas I do believe the quality is getting better, but for a while there, sometimes you get like a stepper motor that would just be broke. You know, you just never really know. So you can see I've got the red and the black connected to B minus and B plus. Ta-da! And these ones right here, I'm going to connect to A minus and A plus. We could follow the legend. See, did I get it right? Tell you what, it doesn't really matter, but I'll be a good sport. There is a legend, and if you have it, you should follow it. I've actually found where sometimes the legend is inaccurate, and it says that Schwartz black is A plus. So let's connect it to A plus. Schwartz. Doesn't really matter. It doesn't matter. Okay, and let's see. A minus is green. Check, check. All right. And let's see, it says red is B plus. Nice. And last but not least, blue is going to be B minus. There we go. So I specifically chose this controller because it runs off of DC 9 to 42 volts. A lot of them need 20 to 60 volts. So this one here it's a cute little guy. It's meant more for like 3D printers, but you know, it just is what it is. 9 to 42 volts. That gives me a lot of variance when it comes to making some things chooch. You got to make them work. You know I will. So the overall goal is to set this up so that kids will be learning. So remember these wires I clipped off extra? Well, wouldn't you know it, there's going to be a time and place where they come back. So I have the enable, I have direction, and I have pull. And over here, I have pull, direction, enable, and then there should be a common ground. Okay? So that means that, see all these enable negative, direction negative, pull negative, all those negatives can be connected together. And I do believe they can also be connected down here. So let's see, that would be my black wire here. And we're going to jumper all three of those together. How am I going to do that? All right, hold on. It's going to require some more wire. I'm kind of thinking that I should involve some of this blue. Yeah, I'm pretty sure that's what I did, is I jumpered all three of those together. And then this guy over here, lucky me, it's written in Chinese. And of course that camera's not going to pick it up because I think it's all this color right here. It's making it not want to focus. All this yellow and stuff, the camera's like, hey, that's a sexy color right there. And it doesn't want to focus on this bland green. But anyway, so that means okay. So this is an instance where I'm going to go ahead and use my Google Lens with my translator. You guys ever use Google Lens? I highly recommend it. Pop over to translate, and it says detect language. And I'm going to shine it on there, and it's going to, yep, there it goes, magically convert the Chinese into English so I can read what it is. And let's see, what is it? Low, medium, and high. Common. Huh. So it's ground. Okay. Common cathode. Wow, they have some really weird descriptors on here. Come here. There we go. $12 to 160 volt input. Jesus, I would not trust this with 160 volt input. So that little symbol right there is input in Chinese. This one here is forward and reverse. Okay, so that's a forward and reverse switch. Stop and go. So that's my power button. Speed regulation. Okay, we knew that. Common yang end. No, that's some part that I don't get. So it says this one here is voltage, and then the next one there is saying common. So that must be ground. I'm seeing, you know, Google Lens gives me some weird responses. Yin, common yang, one common female end 580. I definitely don't get that. Okay, so I would take it that is the ground right there. Okay. So it has to go from here to those three. We'll figure it out, right? We'll figure it out. If it doesn't work, we're going to figure it out. Okay, so I have my power coming in. That's these two pins right here. Again, that one should probably be done with this heavier gauge. Jeez. I don't know if that fits in that terminal block. Let's try it out. Okay. Does it fit? Not too well. Okay. If it doesn't fit too well, then that means I can't use this wire for that. 12 gauge is way too large. I should have ordered some 14, 16 gauge. Let's see, what else do I got? Okay. Let's see. We're getting closer. I've got drawers full of cables down here, guys. All right, that's closer. I've got, you guys recognize those? Trailer wiring hitch colors. Hey, that is another trailer wiring hitch. Let's see, 4 conductor. Why do I have so much trailer wiring? That's so wild. I know why I've got so much trailer wiring. Oh, look at this, guys. Hell yeah. Okay, what is that, 14? That's better. You never know, guys. I always have stashes of cabling. So, just me says, what are we building today? We are building a mess. Specifically, a big mess. However, I am constructing my DC trainer, which is going to be this board over here. It's going to be absolutely fantastic when it's done. As far as I'm concerned, I've never seen anything like it. It was a concept that I had when I was talking with the guys over at Tri-Touch Services, Gary, Knott. Had a good conversation with him, and look at that. I found the correct diameter. Yes. Okay. This is much better. So Gary Knopp and I, we had a conversation about training, because he is also huge on training people. And, you know, it's just one of those things where this is something that I think a lot of people don't understand. So I honestly can tell you guys that there are few devices out there that are as misdiagnosed as motors. Few, very few, in fact. Just people just can't get it right. And heating elements is probably right up there with motors. They've just misdiagnosed them left and right for whatever reason. Here, the stats are written on the motor, and you can use Ohm's law to figure out if the motor is okay or not. I'm a little bit lost at why people misdiagnose things like motors all the time. So if people understand how motors work, they're more likely to make the correct decisions. And especially with students, my goal for students is to get them interested, right? That's the goal of this project. It's going to be super simple. So I'll show you guys a couple things on this board. So everybody else that's seen this earlier, I said that I have 4 switch mode power supplies, and 2 of them are defective. 2 of them are defective. One of them is this guy down here. It's a medical grade switch mode power supply, external power supply, and it's defective. It does not work. So this little jack down here, it plugs in there, yeah, but it doesn't go to anywhere. It just plugs in. But the thing is how do you know if it's working correctly? Well, here's where students should know. First thing they're going to do is they're going to put their meter right here, and they're going to check it, and they're going to be like, hey, wait a minute. You got a bad power supply. There's no voltage coming out. Okay. Did you check the other side too? So specifically on this particular one, you can pull off the IEC, and you can measure voltage at that end. So once you confirm that you have voltage coming in, you have no voltage coming out, you know that your power brick is dead, and you press on. There is no opening it. Don't goof around. Just order another one, right? Unless you're in some isolated location, to which by all means, go inside, because it's probably something simple. However, I have a closed frame and an open frame switch mode power supply. Both these are medical grade. This guy right here is also defective. It has 2 accessible fuses right here on the top. It pops the fuses every single time. And just by chance, right over here is a bridge rectifier that you can get 2 meter leads on if you're so inclined. And you can see that they're shorted. It's shorted. So you have a malfunctioning semiconductor. So everything on this guy looks normal. Everything on this guy looks normal. We have cooling fans on it. This guy here, as soon as I turn this board on, it'll start spinning up, no problem. This guy here, nothing. That's something I want people to get used to. And imagine going into a college or into high schools with this board, and you say, okay, I'm going to show you some skills that you can use the rest of your life. And you got to figure you got 30 minutes to an hour to teach this class, right? So in that, I can teach you how to inspect switch mode power supplies. I can show you how to check a defective power supply. Do you have voltage coming in? Yes, you can measure it. Do you have voltage coming out? You can either measure it here or at the banana plugs. It's up to you. Notice how I have banana plugs at each and every one of them. That will go over here to a switch so that you can open the circuit to the motors, which we're building as we're speaking. So this is a 15 volt. This one here is a 24 volt. And I believe that this big old guy down here is a 12 volt. I could fix it. Maybe someday I will. I think it's better if it's broke. I really do. Because we can, we'll pop these fuses out. I'll throw a couple more fuses in just to, to make the students happy. Hey, the fuses are blown. Put some more fuses in. And here's where they're going to learn a hard life lesson. Fuses do not pop for no reason. They don't. I don't care who the baby boomers are out there that argue with me. Fuses do not pop for no reason. Okay? So the fact of the matter is, if it's popping these, we can disconnect power, and unplug it, And then we can go in and I can show them to look for a short, to which you can measure externally quite easily. So this guy here works absolutely fine. This guy works fine. So, and then using the banana plugs, the students can build their own circuits to the rest of the board, which is what we're doing today. So let's switch back to the overhead cam. I have 3 different types of motors. So I've got a I've got a stepper driver, which is what we're building right now. So I need to create the power wires for the stepper. Actually, should create the power wires for the other one too, because these ones are clearly too large. So let's just make 2 sets. There we go. There's one. See how fast I can make these up. Okay. There's that one. And here we go. And I'm going to go ahead and take a pause on these ones because the last ones, oh no, I didn't put the wiring ends on. Okay, cool. So I didn't terminate them. There's that set of power wires. This is for the 3-phase motor controller. So I'm going to have a 3-phase motor. We can hook it up with an oscilloscope. You can see each of the coils and how they're pulsing. It's going to be awesome. Hold on, let me check the comments here, guys. Sorry. Oh, I've missed the board. You made a video building that. I did for one of them. I watched the AC board with isolation transformer. Yep, that's one of them. That one went really well. I'm really a novice on electronics repair. Left IT in 2018. Became an electrician. Did some electrician besides IT. But I did repair my freezer circuit board and it started to blink the display, turn off and on. I suspect the capacitors and changed to, if something's turning off and on, I normally wouldn't assume it's the capacitors. Interesting. Big Clive is my other mentor. Big Clive's got some good stuff, man. I'm not even in the same realm as him. Not even close. Those guys are just so far above my league. Me, I teach people how I learn, okay? And I figure if this is exactly how I learned, I didn't study in some college or something. This is actually how I learned, is by doing. Sometimes my predictions are wrong, but I always remember when I'm wrong, every single time. And maybe if you're wrong enough, that's why you get to be pretty good at something, is because, you know, you just have a lot of experience. Which is pretty much me in a nutshell, guys. It really is. All right, let's go ahead and do this. I should turn on my ceiling fan that's behind me. Boop. You guys can't see it, but it's right above me. Turn that guy on because I need to run it to see if it's, you know, if it's going to get too hot over a period of time. And let's see, there you guys can see it. Because it's probably not going to stay in here this whole time. I'm either going to sell it or get rid of it. I don't know. But before I get rid of something and give it to somebody else, I want to make sure it's not going to catch fire at their house, you know? So fans are just infamous. If they build up heat over a long period of time, they will just open a thermal fuse and create problems, you know? All right, so let's switch back and let's go back to this guy. Man, I'm trying to organize so I'm not making such a mess. I know it looks like chaos. I should have a better workbench, but it really just is what it is at the moment. Okay, so, all right, too many wires. All right, so here's gonna be my power. And so ground is gonna be the bottom one. And the top one is going to be my power, input power. Ooh, that's a tight fit even for this gauge. Okay, so I think I'm gonna have to cut these down. There we go. I'm cutting my ferrules down because they're sticking out. It's one of those lead by example things, you know. Come on, there we go. So the ferrule sits tight up against the housing. Beautiful. Just like that. When I clip the ferrules, it changes their dimensions. That's why I'm recrimping them. Puts them square again so that they're nice and easy to plug in. Come on. There it is. All right. Okay. So the order for this guy is going to be this guy, then this guy, then this guy. And that's got to be mounted on the board just like so. So I'm going to probably have to drill here. There's 2 tabs. You can see how they want it mounted is like this, which I guess you could do. I don't want to mount it like that. I want to mount it like this so people can clearly read the legend. I know what it says here, but the students won't. And let's see. So I have my enable, my direction, my pole. So let's go ahead, let's see. Do I want this to be longer? I think I want it to be longer. Throw those wires off to the side. Let's see. And yellow. Okay. There we go. Let's clip them. All right, here we go. So there's a lot of prep when you're building this kind of stuff. It's just is what it is, man. You should see how long it takes me to build some things out. And that's just from planning and preparations. Okay, so here's this guy. So these are going to have to be double ferruled cables. Okay. If you guys have any questions whatsoever, feel free to ask. I have no problem stopping what I'm doing to answer a question, man. None at all. I just figured I'd turn the camera on because I was going to be out here doing this anyway, you know? So, since I'm going to be here in front of the computer doing exactly what I'm doing now, I figured we'll just let the camera run. And if something catches fire, then it catches fire. That's the truth. Oh, I like these cutters. Nice. Okay, so there's the first one. I'm chopping the ferrules down a little bit so that they fit better and they're cleaner. Okay, so you can see they're a wee bit shorter. And last wire. Okay, so that's funny. You need to create the thing like it's in its natural habitat. Mount it between two very tight spaces. You are not lying about that. Holy cow. And I was going to do that to those power supplies, is mount them a little bit closer so that you have to really kind of look in between the two. And you kind of can see this little gap right here? I did actually do that on purpose. So that's very realistic. Sometimes you have to really kind of get up in there and look to see what the rating is on that power supply. And I did that on purpose because of that exact same reason. Okay. Yes. All right. So here's my 3 wires. So I think I'm going to connect. I think I'll connect them to this guy first. I've had this guy for years and I've never used it. So this is like my big opportunity to use something I bought a long time ago. So let's see, red is going to be my enable pin. Come on. Wow, jeez. Wow, what the hell? Come on. Let's try recrimping them after, maybe it lost its square after that last clip. Enable. Huh. Well, that just doesn't feel right. It doesn't feel like it's going in much at all. There it is. I just had to rotate it. That's so ridiculous. Okay, so red's my enable. I have a direction and a pole. So we're going to make direction my blue. Recrimp. Jeez, it's so fussy on the direction of the crimp. And last one. Here we go. Let's do it. Nice. See? Ferrules make it look beautiful when it's done. Nice, neat industrial electronics. Not saying that's how it's going to look when it's done. At the moment, it looks beautiful. All right, and I have all of this clippings right here, and I don't know if you guys have ever gotten like wire up inside your arms. Not a good feeling, so give me a second. I sucked up a ferrule. Oh well. There we go. All right, so this is my pulse generator. This guy receives the pulse and the direction. So this guy here basically reverses the polarity. It disables the direction pin. So if it's off, it will go in one direction. If it's on, it goes the opposite direction. This guy receives it, and it sequences the coils either one polarity or the next, okay? And that is for the stepper. So let's see, I've got all these. Now the next thing I need is to jumper the enable, the direction, and the pulse. It's pulse. I know I keep saying pull, P-U-L, but it's pulse. So every pulse that it reads, so this is like a signal generator, and all it does is create pulses. For every pulse, this guy sends out a big pulse in the direction that you told it. So first, enable means I want you to move. Direction is what direction do I want it to move, and pulse is how far I want you to turn. Okay? That is what this legend means. All right. You need to create it like it's in its natural habitat. We'll see, because I might have to mount these kind of like this. I kind of want them to stretch out so people could see, you know, what they're really doing. But now I need to do the fair rules for this guy right here. So the minus, the minus, the minus, and I think it's going to connect down here to the ground pin. So we'll go from here, the ground out, over to here, and jump earth all these pins. There we go. That's how we're going to do it. Let's do it. For the ground, we're going to use the blue wire, because why not? I don't know. I think that's overkill to use that one. Yeah, too large. We'll go with the blue. Ah, shoot. We'll go with the black. All right. I keep thinking about, like, I can figure it out, but I have to keep remembering that a student has to figure it out, you know? Okay, so I'm going to measure out the distance. Good enough. My first clip right about here. And then from here, what we do is we measure it out. This guy to this guy is going to be a little booger like that. One of these guys. You're going to see how I'm going to make jumpers. It's going to be quite quick. This guy and this guy. There. Oh, come on. You see it started pulling some of my conductor. That's not good. When you start dealing with these really short stretches of wire, you're going to deal with that, where it's going to start pulling conductor out of the loop. Okay. So what I'm going to do, you can see these two here. I'm going to combine two wires in one fair rule. I got to make sure that I get the right diameter of fair rule, which I didn't. There we go. Perfect. Yes. Okay. So now you can see how my jumpers are forming. See that? I mean, I could have ran individual wires, but there's no need for that. Okay, so I got my long wire, my jumpers, so I need to clip this guy right here. And let's do this guy here. Man, it's coming together. Look at this. Let's clip it down. And I'm going to get the orientation correct. Crimp this guy on. There we go. Nice. Okay, so here you can see the wire that I just made up. I have to stand up for this one. So what I'm going to do is on the negative pins. This guy's going to go in and get screwed down, and it's going to run back to the ground on the pulse generator. We have to do that because the negative is actually being created by this guy, right? So it's creating a positive pulse on each of these pins, so we have to use the ground that comes from the same source. There we go, there's one. These next pins might go in a little bit tight. Let's see the direction. Jeez. Come on. All right, I think I gotta clip these guys down a little bit. So I'm only cutting about 1 millimeter to 1.5 millimeters off the length of these ferrules. And that gives me all that I need to make a nice, neat presentation. There it is. Beautiful. All right. And this one right here. Tell you what, I could just pull this guy off. Just make sure that you remember what pin goes to what. Come on. All right. So, there are my jumpered pins. Now the other ones, I'm going to use this guy as my legend because I don't remember what wire I did to what. So, let's see, we have pulse. Pulse for this guy is the bottom one. Here. Okay, so the bottom one is pulse. The next one is direction, which is blue. All right, and the next one is going to be enable. And that guy's going to fit in between the two oranges, so it's kind of a tight fit. I'll show you guys how the presentation looks when it's done. All right. Okay. So that right there is how it looks. Now this one here, yes, I can fit it in a little bit tighter. I might not have clipped it short enough. Yeah, I probably didn't. I'm okay with that for the moment. A little bit of exposed conductor. So, as I said before, the one important thing I have to remember is to bring that ground all the way back to the ground terminal of the source. Because if it's not this ground, if I connect it to the ground on this one, it's not going to be the same. Okay, so that would be the second pin right here. And come on, ground. Boy, this socket right here is so fussy. Let's recrimp it, see if returning the square of the ferrule helps. Let's see. That one right there. Yep, it did. Look at that. As soon as I recrimped it, it went in. All right. So this guy can plug back in. And technically, this guy is ready to be driven. So I have to grab a ground and VCC to this guy. So this guy here has a power source, and so does this guy. I would like them, well, this, you can tell this is going to get messy real quick with the wiring. I would like them to come from the same source. Ideally, I could put them in parallel, you know, the two positives and two negatives. I'm going to make a set of wires for this guy as well, right now. There we go. There's a lot of wires to do up on these, isn't there? Imagine when you're building a CNC. I actually wish I had my photos on this computer. I would show you guys how crazy it was wiring up like 5 different motor controllers to one central CNC controller. You know, so you have your computer, then you have your driver, and then you have, or your pulse generator, and then you have your driver. It was crazy. It was really crazy. Fun times, man. So throughout my life, I built 4 different CNC machines, and all 4 of them are still in service to this day at custom woodwork shops and stuff around the United States. I sold them all off and, you know, just pressed on with my life. Okay, hold on. I really don't want to get any copper in my arm. That really sucks. So I have to screw those down right here. VCC and ground. Nice. Okay, so that is technically everything I need to make this guy work. So the way it works is when you turn it on, this guy here will create an enable signal, which will, well, on many of these guys, it'll create a little red light. And the more I turn this, the further or the faster this guy will spin. And then I can reverse the direction, yada, yada. So this is a continuous movement stepper driver, okay? It's designed to continue to create pulses in one direction or the other. It's just how fast the pulses come out are generated by this guy. That's all it is. And this guy here changes the direction. You know, remember I told you there's a direction wire? So this one's going to change it from a negative to positive polarity. And now the pulses are going to mean that it needs to move the opposite direction, okay? So it's not specific. A normal stepper driver will say, hey, I want 10,000 pulses in this direction. I want 320 pulses in the opposite direction. You know, it's very specific. This one's just constant pulses, all right? So that is my stepper system. I've got to find a place for that on the board. Next, I think we just did the 2 most complex ones. Now I have the regular 2-phase PWM controller. Oh, there's something. As long as I'm at it, I might as well clean this guy up. I'm going to go ahead and separate the wires out. There you go. You can see how easy that was. I've got a little choke right here. Here, let's just go ahead and pull it off. So here's a little ferrite bead choke. Don't need it. And I've got a silicone strain relief right here, or leak prevention. I'm just going to slide it off. There we go. So the 2 wires that I don't need, I'm just going to pull them off to the side. These 3 wires right here, let's go ahead and clip them off. That's our 3 phases for this motor. Strip them out. These are nice silicone jacketed wires too. Tell you what, Philips, they know how to build a medical device. I mean, it's super nice. Okay. 1, 2. Let's see, how am I going to hook this motor up? Because if I just connect it straight, yeah, I guess people can still access with an oscilloscope the tops of the screws. We're okay. I just wanted to make sure that people could take measurements and see exactly what's going on with a 3-phase motor. Let's go ahead and put this on. So were you guys paying attention when I said, how do you change the direction of a 3-phase motor? Do you guys remember the answer? How do you change the direction of a 3-phase motor? Do you guys remember? I said it earlier. For a 3-phase motor, if you want to change the direction, you just switch around any 2 wires. Just switch around any 2. So the green and the black, just switch them around. So it's now green and black, black and green. That's it. Now you just reverse the direction of the 3-phase. Since this is a blower, it's going to have a specific direction. In other words, it's really not going to work very well. So I'm going to have to figure that out when I connect this guy up, because it's not going to blow out. You know, it's going to sit there and spin at a really high speed, and it's not really going to do very much. It has a direction. So in order for this cyclone to really work, you have to have it on right. On my 3-phase right here, we have, let's see, hold on. Oh, let's see. Hold on, guys. I'm trying to figure out where I left off. I got my wires. All right, I might ignore some of these. Let's just connect them up. So CB and A. There we go. That's all 3. Actually, you know something? For this 3-phase, we can test it right now before we even continue. Let's do it. The reason we can test it is because I got the DC in right here. Here, let's shut it off. I have DC jacks over here on my wall. I ran a DC power supply all the way over here to the far wall so that I could easily test circuits. Let's see. There's a red one. Here's a black one. Okay. So we're gonna go ahead and hook this guy up, and we're gonna run it right now. What's los?
Are you live?
Yeah.
No, let's go left.
Okay. All right, let's see. I need some longer wires. So let's get a red and a black. Gonna make these some longer leads. Let's go right about here. Nice. All right, let's put some ferrules on it. Oh, that's how you damage your stuff, right? This one. And this one. So yeah, I'm just basically making test leads. that's all I'm doing right now. Here we go. And let's clip them back a little bit. And let's go ahead and put some ferrules on the other side too. Why not? Cool thing about these ferrules, guys, is they're inexpensive. Like, you can buy this whole entire kit for like 30 bucks. So that's why I have no problem with using them and maybe even having to take them off later. Excellent. Here we go. So my leads over here. Let's connect up the red to the red, the black to the black. I know it's janky, guys. It is what it is. And this system here, let's see, what was the input voltage? We're going to start this guy out at 12 volts, okay? I'm not really sure what its rated voltage is, but it should definitely be safe with 12. Or maybe 9. Let's do 9. Because I don't know, I don't know what that motor's rating is. Okay, let's see. Okay, here we go. So my motor is technically connected right now. It might not be in the correct polarity. Remember, guys, I told you it's possible to reverse the direction by having them incorrect. It's a 50-50 shot, right? So we're currently off. This guy is off. All right, this is a non-conductive platform, so we should be all right. Minus some of the filings that are just sitting here because I've been clipping. Last thing I want is to have a short. Okay, let's move this stuff out of the way. So I'm going to disconnect my leads over here and set it for 9 volts. Okay, I'm currently at 14. 12, 11. Okay, 9.2. Here we go. We're live. And let's see. We're on. Ah, guys. Woo! Here, watch this, right? We have a red light. It is working. So here's the thing about 3-phase. So let's see what happens when we reverse the direction. Okay, as I said, we're going to take, so right now it's black, green, and yellow. Let's go ahead and reverse 2 of them because it might still blow out, but it might not be as efficient as it should be. Uh-oh. Hey, hey, hey. Okay, let's reverse these 2. That would be just wild if I got it right the first time. Okay, let's see. Here we go. We're on. Oh, there's a big difference. Holy cow, guys. Look at the light is brighter. That's interesting. It actually has a bit of static pressure. Okay. So one of the first things I noticed is that this guy sits here and it stutters a little bit when you activate it, which is really kind of weird. Let's see. I think I have some other three-phase motors here to demonstrate this principle. Let's see. Hold on. I'm pretty sure I got some other three-phase motors. It's just I've never had a three-phase motor controller in order to test them. So let's see. What do we got? I did have some motors from Power Tools. And that one is a two-phase. Huh. I have a whole drawer full of motors and stuff down there, but I don't really want to fish around in it. Darn it. Well, this one here is a two-phase, but it's a positional two-phase. Oh, you know something? How about this one? Let's do this one. Let's prove a point. So here's a three-phase motor, that hobby motor that I was telling you guys about. Let's go ahead and set that guy up. I don't know how we're going to do it, but let's do it. How am I going to set that guy up? Gator clips. Gator clips. That's what I'm talking about. Okay. So here's a red and a black. And a blue. One, two, three. Okay. I have these silicone jacketed test leads, so this is what we're going to use to do this. Okay, so let's go blue to blue. Black to black, and red gets yellow. Okay. So this motor might actually just booger off. It's got so much torque that it could just take off and, you know, jump off my desk. So here we go, here we go. We're just dealing with low amounts of electricity here, guys, so not a big worry. And I think I have the regulated DC power supply. Not only is it only set to 9.2 volts, but I think it's current limited, so it's going to be on really low current. So this is going to be really janky, guys. You're going to have to forgive me for it, but it just is what it is, man. So here we go. I have 3 needles on my test leads. I am going to screw them down. Yes. And we are going to see if this motor jumps off my desk. Okay. We should be good. We should be good. Here we go. Oh, yeah. Okay, right now it's counterclockwise. Oh, yeah. Yeah, it's counterclockwise right there. Oh, and I'm current limiting. That's why it's not going any faster. Okay. So right now it's counterclockwise. We're going to change these two, the red and the blue. So let's see if there's any fancy circuitry in here which keeps the orientation correct, because it should reverse the direction. Okay, here we go. Oh yeah, here it is, clockwise. There you go. It is what it is, guys. So, changing any two wires changes the direction on a three-phase motor. Oddly enough, it did not on this guy, as far as I know. You seen how it staggered though? The rotor would sit there and kind of stagger like this. I'm really curious why that is. What's going on? There's something going on in here. You can see that there's a speed sensor or a directional sensor, one or the other, right here. I don't know what it does, but it's there. Yep, there it is. How cool! So that just goes to show you. Three-phase. Simple tech. This is the future though, guys. Right here. I think I did a video on three-phase. I can't really remember. You know, when you get to like 850 to 900 videos in on something, you just forget like what you did and what you might have done, and I don't know. All right. So that's why I always keep these silicone jacketed leads around. You can do test fixtures really quickly with them. Okay, so this guy is verified and it works. Let's go ahead and disconnect our power. And let's see. Do you guys think I should test out the stepper? Let's do it. Let's test out the stepper using the same leads. Okay. So this guy's working. Here we go. So I'm going to have to strip these and put them in parallel. That's pretty apparent. Okay, let's do it. All right, so I need to put these in parallel, and I'm going to do that with 2 gator clips. I know everybody's going to be like, why the hell is he doing it like that? So I'm going to wrap the cables around here to keep them nice and taut, all right, so that they don't booger off. Let's stretch these guys out so nothing gets caught up in here. Okay. So red gets yellow, black gets white. I'm gonna move that stepper up there. I should put a flag on it so that you guys can see it moving. Hold on, let me get my tape. There we are. All right. And this is kind of what I was going to do anyway, because this is how you show that a motor has movement. You should put a flag on it, like so. Okay. So black to black. Wow, this is not going to be good. All right, let's put the motor over there. Black to black. This is such a mess. All right, there we go. Red to red. Red gets yellow. And again, we have it currently set at 1.75 amps, 9 volts. Let's see, what is the voltage they recommended? I think I'm gonna turn the voltage up to 10 volts. Let's turn up to 12 volts. Okay, we're gonna go 12. All right, let's do it. Let's turn it on, disconnect one of my leads. I'm at 9 volts. 10, 11, 12.1. Okay, here we go. We're good, we're on. Okay, so this is the enable, this is my direction. And here's my motor. So this is the part where you got to figure out what is going on. Okay. Since this is in Chinese and I don't know what the heck they're trying to say. So this right here is in FPEQ or PWM. Right now it's in FPEQ. And I also have a ground jumper that I can move around. Okay, shut it off. And let's try moving the ground jumper. There's no literature that came with this whatsoever. And also, yep, okay, so we got a blue light on this guy. And these, the switches right here coincide with this legend. So let's go ahead and shut it off. And let's set our micro switches. We are not going to set it on a micro step. So on this one here, S1 is on, off. It says on, off. There we go. And current, 4, 5, and 6, that's on, off, on. On, off, on. Okay. So I set the current at 1 amp, which this guy should be able to handle 1 amp. And I set it for 1 on the micro step. Not saying that solved my problem, but I did have to adjust my steps. Oh, yeah. Well, I can tell you one way that you know that it's working is the motor is completely locked up. Like, you can't move it. It's locked up tight. So one of my jumpers over here has got to be changed. So one of the things that you should know about stepper motors is, actually let me turn the current down because I can feel it getting warm, like really warm. So we're going to set it to on, the minimal amount of current. On. Okay. So the thing about stepper motors is that they are always on, like always. It's 100% power to both coils, so you can't move it. It's static power, I guess. So anyway, that is how they're rated at their holding power in ounce, inches, or whatever. And you know, obviously the bigger the motor, the stronger that's going to be. You can adjust that based on your current. Also, your holding power is going to be based on your micro steps, because the smaller the amount of steps, you know, the less current you're going to have holding it in place at one time. So I felt this guy getting really warm right off the bat, so I turned the current down. Now, when you power up a stepper motor, it's locked. It will stay stationary until you tell it a direction and a pulse. So I need a direction and a pulse from this guy to make it go one way or the other. And that is the part that I just don't know. So it's kind of crazy because I got this jumper, but it's in Chinese, and even when I did the translation, none of it made sense. Also down here, I got the FPEQ or PWM. And disconnect it. So I'll disconnect this guy over here, and I'll change that jumper to PWM, although it should be an FPEQ for steppers, I believe. We'll find out together. I've never adjusted it. I literally just took it out of storage and went to hook it up. Okay. Yeah, this guy is pretty much locked. I have the current turned down quite a bit because it doesn't need to get hot, not for the demo that I need to give. I think what it is the ground from this one is not coming over to this one. And we can kind of simulate it by going from the ground on this one to here. So it's got like an overcurrent protection. That's weird. I will have to study up more, or I will just have to get a different controller, because this guy is garbage. It's garbage. And I know I got the motor hooked up correctly. 100%. Okay. Well, the stepper motor is a no-go at the moment. I got to figure it out, and I'll just figure it out off cam. I do have a second stepper pulse controller. Let's see, where is it? Where is it? Okay, here's the next one we're going to build up. Where is that other pulse controller? Jeez. Oh, over here. My bad. It's just not as beefy as the first one. It's almost the same setup, but it's not as beefy. You can see that this one here, they have the semiconductor heat sinked to the board. This one here, it's actually got a heat sink. They're almost identical. This one's got a lot more jumper settings. This one does not. I don't know. Just is what it is, guys. So if I can't get that one to work, I'll switch over to this one when I put it on the board. You can see they have some solder mass on the back to help it with its thermal. So the frequency, and now it should be on frequency. Jeez. Frequency or PWM? I am pretty sure I had that guy correct. So frequency, I think it's just my negative down here. Something about that negative. Tell you what, let's measure it. Darn it, where's my oscilloscope? So because it's generating pulses, we can see that on a scope, and we can determine if we have a faulty component. All right, for all you guys that say we never use oscilloscopes, shame on you. Okay, there we go. Oscilloscope probe. Let's hope it's charged. A lot of these Chinese scope meters, they lose their charge when they're in storage for like a week. Come on, power up. There we go. All right, we're good. Okay. Set my scope probe up. Now, there is a chance that it will not be generating pulses if it senses a error condition, right? We don't know. I definitely don't know. Let's see. It's not going to be the easiest to get on that negative pin. Okay. So here's how I'm going to have to do it. I'm going to get out my screwdriver on the negative pin. And let's see. I do have a pulse. Oh, you guys can't see it. Hold on. I need to have that same type of scope meter or live readout that Louis Rossmann has, man. That would definitely help out. So here's the enable pulse. You can see it right there on my scope. Let's go directional pulse. There's a directional. And here is the pulse for, oh shit. Let's just pull this guy off. And let's go auto. There we go. That's what I want to see. You see it? So, see that? That is what we're doing to the stepper, as we're increasing the pulse, and that is going to increase the speed over here. Although, that looks like PWM. That's not frequency, guys. That's PWM. You see how it's expanding the pulse width? You see that? That is PWM, like on a PWM motor. That jumper might be labeled wrong. Or I might be an idiot. What? Who knows? Come on. Yes. Good thing this is low voltage, right? So what do we got on this guy? We get the exact same thing. So the frequency is not changing. It's still behaving like PWM. Let's do on. Let's change it back. So it's supposed to change the frequency of the pulses. And I'm at 5 volts, 272 kilohertz. Yeah, it is changing the frequency. It's just the meter is compensating so fast. It's on auto mode. If it wasn't on auto mode, you'd see the amount of pulses increase and decrease on the screen. It's triggering right here in the middle, and it's keeping it centered. User error, right, guys? Okay, so let's go to the direction. So I'm on the direction pin right now. Auto. So when I change the state of the direction, it's really not doing much of anything when I change the direction. That's interesting. Okay, let's go to the enable. So clearly you guys can see that I have something on my enable. Wow. Okay. Well, I'm clearly going to have to play around with the jumpers and figure out what the heck is going on with that. Okay. That is what it is. Anyway, let's see. So, guys, let's switch the camera up. So, my concept is to build this guy out. Now that I got my motors set up, the only one that I don't is the PWM. This is the easiest. There's only 4 wires. So I'm going to figure out the layout for this guy, and I believe tomorrow I'll probably be doing a live stream where I actually install all the rest of the ports and lay out the motors, especially once I go through and troubleshoot this bad boy over here, figure out what's going on with it, and then I'm going to install these ports throughout so that we can just do jumper to jumper. And today I'm also going to be making up a bunch of jumpers, which are the 4mm banana to 4mm banana, so that people can, you know, play switchboard operator. But that's the goal. So anyway, guys, I'll do my legwork, including troubleshooting this guy to see exactly what's going on with it. It's playing a little hard to get, and it's starting to look like this guy's a defective part. I have a second oscilloscope that might be a little better than this one. I'll look it up on that guy to make sure it's doing what it's supposed to. And I will lay this guy down and lay the parts out so it makes logical sense. And then we'll go ahead and I'll do a live stream tomorrow where we just go ahead and start fastening them down and finishing the product. Sound good? All right, guys, typical. Not everything goes as planned. It just is what it is. You know, honestly, this part here has moved across states with me and stuff for years. I've never used it. Had no idea if it's right or wrong. I might even just get another controller because I really don't like when something is written in a another language. I don't like it when it's written in another language and there's no documentation whatsoever, which is exactly how these parts show up. So it's fun to try and figure out what they are, but I need it to make sense. So if I can't figure it out, it's gone. That's all there is to it. Okay, guys. Well, I'm going to let you guys go. Y'all have a fantastical weekend. I'm going to go in and help out with the kids and whatnot, and then do my legwork on this project for tomorrow. Tomorrow's going to be a good day. All right. I'll see y'all later.